Okay, so part 2, just some more questions from the A-level spec. So this is from chapter 7, I think. So this is factor theorem and remainder theorem. So use factor theorem to show that x plus 2 is a factor. Factor theorem is where you simply substitute in a suitable value. So if x plus a is a factor, that means that f of minus a equals 0. So I'm going to use that fact here. So I wouldn't write this out. I'd simply just put x plus 2 factor implies f of minus 2 equals 0. So I'm just going to show that. So f of minus 2 is equal to 2 times minus 2 cubed minus 7 times minus 2 squared minus 10 times minus 2. There's 24, and I just want to work that out. So a lot of this, I'll just skip to this line here. And so minus 2 cubed is 8 minus 8. So minus 8 times 2 is minus 16. Minus 2 squared is 4. So this is going to be minus 28. This is then a plus 20. And then this is a 24. So I've got a 44. So these first ones were negative. I had minus 16. Forgot what I said here. Minus 28. And then these ones were plus 20 and plus 24. So 24 take away 16 is 8. 20 plus 8 is 28. Minus 28 is 0. Job done. Use calculator. Factorize completely. So I know that it's a factor. I'm now going to use long division. So I'm going to start up in this top corner for long division. So we have this in a couple of ways just to show you some different techniques. So this is the usual long division way. So x into the first one, x into the second one, x into the third one, and so forth. But make sure you subtract. So x into 2x cubed is 2x squared. Multiply through gives me 2x cubed plus 4x squared. Subtract these. Minus 7 minus 4 is minus 11x squared. And bring down that next term. X into minus 11x squared gives me minus 11x. And then multiply through again. So I get minus 11x squared minus 22x. And minus 10 minus minus 22 gives me 12x. Again, I'm just going to put that line in just to show I've subtracted. And then I'm going to bring this other term down here. Finally, x into 12x gives me a positive 12. And then multiply through gives me 12x plus 24. A number take away the same number is always 0. So as long as everything aligns here, you're good. Therefore, we've got a factor. If this isn't 0 at the bottom, you've gone wrong somewhere, because we already know it's definitely a factor. So the remainder should be 0. Once you've done that, you're looking to factorize. So we know now that fx can be written as x plus 2. I'm getting messy here because I'm going in the middle. Try and keep your work neat, please. Have a little bit more coherence to it, a little bit more organization. I want to factorize this one. A couple of ways to do that. You can do it properly. You can do first times last, whatever way it works for you. I'm going to try and do inspection. So I've got 2x here, and on this one I'll have an x. I know it's a positive 12 here, but a minus 11. So they're likely to be both negative here. But we'll find out in just a second. So I'm just having a quick think of what this could actually be. 4 and 3 both make 12. So if I make this one 4, a negative 4, and this one a negative 3. Minus times minus 3 times 4 gives me 12. Minus 4 times 2 gives me minus 8x, and minus 3x gives me this minus 11x. And that's your lot. The other way to do this would be to cheat and use the calculator. So if you want to solve this in the calculator, that'll tell you the roots, and we can work backwards from there. So if we're putting this in the calculator, we've got a polynomial degree 2, and it's 2x squared minus 11 plus 12. And that tells me my first solution is 4. That's this bracket here, x minus 4. So I can put that straight in. My second bracket solution is 3 over 2. Now the 3, first this is positive, so we reverse the sign to negative. Top number is the actual constant, and the bottom number goes in front of the x. So that's a quick kind of way of doing this. That 3, change the sign, it's negative, and that 2 just goes in front of the x there. And just to factorize that. So if you wanted to cheat a little bit, that's always going to work that way. Yeah, and that's it. That's the full factorization for 4 points. Final thing to say on this one is there's a slightly faster way of doing this long division, and it's known as synthetic division. It's a bit of again, a little bit of a shortcut, a bit of a cheat. You don't get full understanding, but it works. So the big thing, x plus 2, that means that minus 2 is the factor that goes on the outside. And then just along the top here, what I'm going to do is I am going to simply put in the coefficients from my original function. So I've got 2, minus 7, minus 10, and 24. This 2 comes straight down. So this 2 simply just comes straight down here. And then what you do is you do this minus 2 times this 2, which is minus 4. And then you subtract these. Sorry, not subtract, you add these. So minus 7 plus minus 4 is minus 11. So that then comes down to here. You then do minus 2 times minus 11, which is 22. And again, you add these two together. Minus 10 plus 22. Minus 7 plus 22 is 12, so that comes down here. 12 times minus 2 is minus 24. And this bit at the end here will be your remainder. It's 20, sorry, this should have been minus 2 times 12, which is minus 24. 24 plus minus 24 is 0. This bit's your remainder, and this is the coefficient. So this is the constant, the x, and this is the x squared. So this will be constant, this will be x, this will be x squared. Whatever it is, you'll stack constant and work up. So this is 2x squared minus 11x plus 12, which is what we got. Synthetic division is quite quick, it's quite neat, but you've got to be careful not to make a mistake using that, because it is a little bit of a trick. Right, that's enough talk about that 6 marker. Obviously, you could have done all that a lot faster. I've just been talking away. Next up, binomial expansion. I'm not sure I'm going to have room for binomial expansion here. Let's double check. Yeah, I think we can maybe squeeze this in. So I'm going to start down the bottom here. So A. So binomial expansion, there's a few different ways of doing this. I myself use a little bit of a hybrid. But you've just got to remember it's the NC. So each term is NCR multiplied by. So that's n choose whatever you're looking for. Multiplied by this number. So let's call it A. So if this was A plus B to the n, it's times by A, then to the power of, in this case, it'll be n, but how are we going to do this? I'm just trying to think of the formula here. It's basically decreasing powers, so I just need to get the formula right here. So it's n minus r, and then the b will be to the power of r. So that's correct on that. So this NCR is going to tell you the combinations of which kind of this multiplies out. The a to the n minus r is going to be the power of a that goes in, and the b to the r is the power of b. Notice that n minus r plus r always makes n. So these two numbers will always add up, in this case, to be 4. Phew. So the first one starts with just your normal number, though. So it's 2 to the power of 4. That's the first term. Plus, now I'm going to do n. So that's 4. Choose 1. So this was 4 choose 0. So that's why we don't use that there. So 4 choose 1. This n choose 0s always 1. So 4 choose 1 times 2 to the power of 3. So that's now decreased from 4. And now this minus 9x comes in to the power of 1. So that's my second term. My third term is 4 choose 2 times 2 squared times minus 9x all squared. Now remember to put this in a bracket because that minus 9 will be affected by the power. And then just tidy this up. So 2 to the power of 4 is 16. 4 choose 1 is 4. So I've got 4. 2 cubed is 8. So I've got 4 times 8 and then times minus 9. So I think that's 288 minus 288, I think. Ooh, oh, that's the next question, sorry. Just trying to get my pen to actually work. There it is. Minus, I think it's 288. Let me just check that. So 4 times 8 times negative 9. Yeah. No need to doubt myself. And the next one, I've got minus 9 squared, which is 81. 81 times by 4, and then 4 choose 2, I think is 6. But again, it's best just to double check. Yeah. So I've got 6 times 4 times 81. That minus is going to cancel out when I square. So it's 1,944. And that's x squared. So that's my first little bit of this question. I'm actually going to just move that up to here, just so I've got that. So 16 minus 288 x plus 1944 x squared. And I'm just going to put on at the end here minus dot dot dot, because there's going to be other terms at the end there. I'm now going to just rub all of this out just so I've got a bit of space. So I'll just take a second. Okay, so next up we've been told that we've got the same number, but we're going to multiply it by some kind of other function, I suppose. So the other function itself is 1 plus kx, where k is a constant. We know that this expansion of ascending powers of x is this here, and I'm asked to find what a and b are. So I need to find what a is, what k is, and what b is. So the first thing I'm going to do here is just write this out again, but with this expansion. So for part b, I'm going to start by writing out 1 plus kx multiplied by, and then this thing here. And we're going to talk about the cross multipliers that could happen from here. Now, I don't care about these other terms. I just like to put that in for consistency. So in order to get a constant from this, the only way I can get a constant is by doing this 1 times 16. Any other combination of these multiples or multiplications will give me non-constant. So the a must be 16. So it's only worth 1 point, and that just comes from this multiplication here. But let's just do some of these. So if I want to get a, I do constant. That's that times that. That's going to tell me 16. Now when I do this times this one, that's going to tell me a minus 288x. That's not my only x term. I get another x term from doing this kx times 16. That's going to be a plus 16kx. That's going to be quite important in a second, because we know what our x term actually is. So I'm looking at this and I can see that k is actually going to be some positive constant. We'll find out in a second. And then lastly, I've got the x squareds. So to get the x squareds from this, again, it'll be 1 times by my x squared term. And then I've got this kx times by that same term. So I've got this plus 1944 kx squared, just trying to squeeze that in there. Oh, yeah. Oh, sorry. It's not that one. Completely messed that up. Ignore that last little bit. It's that kx times by the one before it, sorry. Let's think before I speak. It's this one here. So it's kx times by this. So I've got a minus 288 kx squared. That would have been clearer in a second. That kx times by this term will give me a cubic, which we don't want in this. Okay, so we can see from this that a equals 16. That's fine. So we're good with that. So that's for part B. For C, to find k, we're going to use this next one. So looking at the coefficient here, I've got this minus 288 and I've got plus 16k. And I know that needs to equal the coefficient over here. So I know that minus 288, when I add 16k to that, I'm going to get minus 232. So I just have to solve this effectively. So I can see from this, if I do minus 232 plus 288, that's going to tell me what 16k is. And then when I divide by 16, that tells me that k is going to be 7 over 2. So not the nicest number here, but some positive value. Stick that in a box. And lastly, for b, I know that b is equal to this, but the coefficients of this. So it's 1944 minus 288 times by k. So for b, I know that's equal to 1944 minus 288 times by 7 over 2. And I just have to plug that into my calculator. So 1944 minus 288 times 3.5, 936. So B is 936. And that's that one done. Not too bad. Okay, next question. We had a sneak peek a second ago. It's to do with differentiation. A little bit of optimization, maybe. Bit of a tricky one is this one. So it's a solid glass cylinder, which is using an expensive laser amplifier, has a volume of 75 pi centimeters cubed. There's a lot of noise going from outside. The cost of polishing the surface area of this glass is £2 per centimeter squared for the curved surface area and £3 per centimeter squared for the circular top and base. Given that the radius of the cylinder is r, show that the cost of polishing is given by this particular thing. Right, I'm going to do this question. I'm just going to cover that up for now. I'm going to do it over here. So there's a couple of bits of information we're given here. The first thing is about volume. So we know that volume is 75 pi centimeters cubed. I'm just going to write that there. The second thing we're asked to talk about is this surface area. So I'm actually going to draw a quick picture of this weird looking cylinder. It's a standard cylinder. I'm not told anything about the height, so let's put that as h. And I'm not told anything about the radius. Let's put that as r. Yeah, that's it. All we know is something along those lines. And we've got to find everything else from this. But we do know that the volume is 75 pi. We also know that the volume would be pi r squared times by whatever h is. So in other words, we know that r squared times h is equal to 75. So it's a very, very important bit there. Yeah, that's literally what we're getting there. So we know that r squared h equals 75 by equating these two and then dividing by pi. So h is equal to 75 over r squared. So that's going to come in handy in a second. So it's really important to get that first. Now let's have a look at the surface area. Surface area of a cylinder, we've got pi r squared. We've got that twice though, one for the top, one for the bottom. And then we've got the curved surface area. Now, the curved surface area, if you roll out a cylinder, you get a rectangle. The top part of the cylinder, this is the bit that would be wrapped around the top. This is the circumference, so 2 pi r. That's the circumference of that circle at the top. And then this bit, that's just the height. So our thing is 2 pi r times by h. That's the curved surface area. Again, it's important not to forget that. Easy enough if you know how to derive it. Phew. From here, what we want to do is firstly substitute what h is, and then we need to calculate the cost of these. So we know that it's £3 for each bit of this. So I'm actually, the cost itself is going to be £3 times by whatever this is, plus, and then it's £2 for the curved surface area. So it's £2 times by 2 pi r, but then don't forget h is actually 75 over r squared. I'm going to whack that in there as well. Just enough room. Just need to simplify that now. So c is equal to 6 pi r squared. And then this, we've got a load of stuff going on here. 4 times 75 is 300. And then r divided by r squared leaves us just an r at the bottom. Compare that to what they give us. And that's it, so 4 points in the bag. Next up, it says to use calculus to find the minimum cost of polishing, giving your answer to the nearest pound. Okay, so we don't know technically it's a minimum yet, but we can just assume that because the question's saying so. All we're going to do is differentiate this. Now I've got a c and an r, so technically I'm doing dc by dr is equal to 12 pi r. And then this one is r to the minus 1. So the minus 1 comes down to give us minus 300. And the r to the minus 1 becomes r to the minus 2, which is r squared at the bottom. From this, you know it's a minimum or a maximum. So you know that that implies that this equals 0. So the fact it's a minimum means I can set this equal to 0, which I'm going to do here. I should really write it again. And then I want to solve this. So I'm going to times through by r squared to get 12 pi r squared minus 300 is equal to 0. Taking the 300 across divided by 12 pi gives me r squared equals 300 over 12 pi. And then I'm just going to whack that in my calculator to find what r is. Remember, this is going to give me a plus and a negative, but a radius can only be positive. So we're talking about a length here. So I'm just going to put that in there. So it's 7.95, blah, blah, blah. Dot, 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 dot. So that's my radius here. It's asking us actually to find the cost though. So the cost itself, we need to use that radius. So using that, I'm going to put it back into my C formula. So I'm going to put 6 pi ans squared. So remember my ans is that value, plus 300 divided by ans. And then it equals, and we get that, that's the cost. So 123. It says to the nearest pound as well, I think. Yeah, to the nearest pound. So we'll do that in a second. So 123.3611 dot dot dot. So it's the nearest pound. We know it's 1231 pounds. Okay, part C is saying to justify that this is a minimum. Remember, to justify max mins, you do the second differential. And you just whack in your value of r and find out what that comes out to be. So we'll come on to that in a second. I don't know where to shift my calculator here. We want to differentiate this again. So I've got 12 pi. Now, this would be an r to the minus 2. So when you times that through, it's going to become a plus 600. And then the bottom number is going to change to an r cubed because that's going to a minus 3 instead. And into this, we're going to put in the value of 7.955 kind of business. Now, there is a cheating way to do this in your calculator. I'm just going to put it in first to show you. So 12 pi plus 600 divided by ans cubed. So this is positive, therefore this whole thing is a minimum. So this is equal to 38.9, which I'm going to justify here. This is a positive number, which implies min. That gets me the point. In actual fact, you want to differentiate this at the point 7.95. So if you've still got that saved as your answer, you can use this differentiation button here, which I want to differentiate 12 pi. I'm going to use x here because it's what your calculator knows, minus 300 over x squared, because I'm using this function here. And I want to evaluate that at my ans. If I press equals, I get the same answer as what I just did there, and I had to do absolutely no work for it. Fantastic. That's the 1 point there in the back. Next up, I'd still tell my examiner that I'm doing the second differential. Next up, we've got curve C, and again, we're looking to differentiate, and it's about tangents this time. So I know tangents can be a bit of a tricky one. Same for normals, very similar. My first thing here is dy by dx. This is not a very tidy looking kind of thing. It's not going to be nice for me to actually differentiate. So the first thing I'm going to do here is to expand as much as possible and simplify. So I'm going to expand my top row, so I get x cubed. And then I'm going to get this plus 4x but minus 3x squared. So I'm going to go with the minus 3x squared first. I'm going to get a plus 4x from here. And finally, I'm going to get a minus 12. And on the very bottom, I'm dividing by 2x. So I'm now going to go through and break this down into term by term. So x cubed over x is x squared, and it's going to have a 2 at the bottom because of this. Minus 3x over 2 plus 2 minus 6 over x, or 6x to the minus 1. This is my y. Well, now that I've broken it down, it's this that I'm going to differentiate. So I'm not going to get ahead of myself. I want to make this as simple as possible and then differentiate. So differentiating this one gives me x. So times by power, remove power by 1, so it just gives me x minus 3 over 2. And then that's going to disappear. This one is going to become a plus 6 over x squared. Part B is find the equation to tangent to see where x is minus 1. Give your answer in this. So we're going to put minus 1 into this. The first thing I'm thinking though, so I've got my x is minus 1. What is my y? Because remember, if you're finding a tangent, you need a point on that line. So I'm going to start by finding my y. So if I put minus 1 into here, Minus 1 squared is 1. 1 plus 4 is 5. Minus 1 minus 3 is minus 4. I'll be timesing those together and then dividing them by minus 2. So minus 20 divided by minus 2 is 10. So this point here will have a value of 10. So I've got my x and my y. I now need to find my actual gradient. So dy by dx, evaluated when x is minus 1, is equal to, and I just want to whack it into here. So I've got 6 plus 3 over that, sorry, minus 3 over 2, and then minus 1. So minus 1, minus 3 over 2, and then this will be just 6. So I just have to work that out. You'd think I'll be able to do that faster. It's 7 over 2, I think. So let's see if we can do that faster on our calculators. So my calculator can, again, it can differentiate at certain points. So this button here can tell me when x is minus 1. I just have to tell it what to differentiate. So in here goes the original function. I can actually, crazily enough, I can actually put in the very original function as well. So I'm going to put in here this thing. And then divide by 2x. If I press equals, I get 3.5, which is 7 over 2. Fantastic. That's the gradient. Now what I want to do is use either y equals mx plus c, or y minus y1 is equal to mx minus x1 to find this line. So now I'm just going to put y as 10, y1 as 10 and x1 as minus 1. So I've got y minus 10 is equal to 7 over 2 x plus 1, because a minus minus is a plus. And then just rearrange this. So my final thing that I'm going to do here, and you can times through by 2 now if you want. I'm going to leave it for a minute. So I'm going to get 7x over 2. And then here I've got plus 7 over 2, but then I'm adding this 10 as well. So it's going to be a 27 over 2. Yeah, 27 over 2. And then you want it in a certain form here. So I'm going to move everything across to where the y is and multiply by 2. So I've got 2y minus 7x and then minus 27 is equal to 0. That's the final form they wanted. So I've times everything by 2, and then I've moved it all to the left-hand side. That's that one. Now let's move on to some statistics. Oh no, not statistics, some integration. Got how many questions we've got here. Figure 3 shows a sketch of part of the curve with equation y equals this. Okay, yeah, I'll make this the last one. We've already got some statistics videos, so I'll make this the last one from here. So the figure 3 shows a sketch of part of the curve with equation this. The curve has a minimum point at k, so that's right here. Region R, shade in the figure, blah, blah. Show that this is 256 over 3. So I'm told everything. I'm also told that I need to do no graphical and no numerical methods. So I need to show this properly. First thing that stands out to me is this minimum point being k. So x equals k for this minimum point. A minimum point occurs when dy by dx equals 0. So that's the first thing I'm going to show here. So y dash is equal to 6x squared minus 34x plus 40. Where does that equal 0? Well, my calculator will tell me. Let's do this. Bit of a cheat sheet. Polynomial of degree 2, 6 minus 34, and then 40 at the end. So I get 4 or 1.6 recurring or 5/3. So x equals 5 over 3 or 4. Now it's obvious hopefully which one this is. 1.6 recurring must be before 4, so that's going to be the maximum. So this k must be the 4. And I'm going to underline that just to say that I understand that. So it's this value right here. Because now we can update that to being 4, we're now going to integrate between 0 and 4. So in order to get the area under this, we need to integrate between 0 and 4. I think actually I'll do one more question after this, just to do a bit more integration. So integrating between 0 and 4 of y with respect to x. So integrating y is over here. So integrating this, adding 1 to the power of 3 becomes 4. 2 divided by 4 is a half. So it's x to the 4 over 2. Just move the calculator right over here for now. This one, adding 2 to that becomes 3. So I've got a minus 17 over 3 x cubed. And then plus x has become squared, so it's going to become 20x. So there's a big thing. They've made you do integration and differentiation in the same question. Be very, very careful. And then on here, I can put this in my calculator. I'm going to do it manually. Why not? So 4 to the power of 4. Oh, I take it back. Maybe I want. It's 256 divided by 2 is 128. So I've got 128. Minus 4 cubed is 64. 64 times 17. Maybe not. Maybe we'll do this in our calculator after all. But I'm going to have 17 over 3 times 64. And then plus 80. When it's 0, it's all going to become 0. So that's what I'll subtract. So 128 minus 17 over 3. I'm disappointed that I'm not doing this in my head too. Times 64. And then plus 80. I get minus 464 over 3, which is not what I've got there. What have I done wrong? Let's just double check. I'm guessing I've put one of these numbers incorrectly. So let me just double check that again. So 4 equals, I'm going to put that as the ans. So I've got ans to the 4 over 2 minus 17 over 3. So the beauty of this question is when you do make a mistake like I've just done, you can go back and error check. Yeah, so that means I've got one of these wrong. I'm going to guess that is in my integration maybe. So I'm just going to double check my integral. And then if not, I'm going to check before it. So I'm going to actually use a calculator to double check this. So I've got 2x cubed minus 17x squared plus 40x between 0 and 4. Yeah, you see that's coming out to be the right answer there. So I've absolutely mashed this up somewhere. I just need to find out where. So integrating this will give me x to the 4 divided by 4 gives me this. Integrating this one gives me a 3 divided by 3 gives me this. And integrating this one gives me a squared. I missed the squared off the end. So me. There we go. Simply comes down to that. 4 squared, so that's not 160. Not 80, sorry. 4 squared is 16. 16 times 20 is 3,200. So now I'm going to go back to that calculation and just update that last little bit there. Wait, is it 3,200? 4 squared 16, 160. No, it's 320. An absolute doyle. There we go. Hey. So when your brain actually starts to work, unlike mine, you can actually go through and find that out. That's your final little bit, and out will pop your answer. But the idea here is just to show you how you can use your calculator for error checking as well. And so it's very good for that. Questions like this are great because you know what you're looking for. Let's try one where we don't know what we're looking for. Final one. Oh, I already regret it by looking at this. The curve has a turning point at A. Using calculus show that the x coordinate of A is 1. Not a problem. So we know that just like before, turning point means y dash is 0. So we're going to set equal to 0. So that implies that 0 equals, differentiate this now. So I've got 12x squared plus 18x minus 30, and just solving that. Again, we'll just cheat with our calculator. You should do yours properly every now and again to check you still can. So 12, 18. So just remember all these are actually divisible by 6. So you should divide through by 6 to make it much nicer for yourself. So I get 1 and 5 over 2. So x equals 1 or minus 5 over 2. It's clearly 1 because that is in the positive quadrant of our x-axis. Job done. The curve crosses the x-axis at point B, which is 2, 0. So we know this is 2, 0. I know that this bit here is 1, 0. And C, which is minus a quarter. So over here we've got minus a quarter, 0, and just for C. The finite region R is shown in this figure, blah, blah, is bounded by A, B, and the x-axis. Use integration to find R. I think this is actually easier than the previous question. You just got to use a little bit of logic in it. So the first thing I'm seeing here is if I was to integrate from C to B, I'd get this weird curvy shape here that I don't want. So I'm actually going to integrate from C to A of my curvy line function. And what that'll do is it'll draw a line down here, and it'll calculate everything on this side of that curve. Now, that'll tell me the area. Hopefully you can see on this side, I've got a triangle that I can work out, and I'm just going to add those together. So I'm going to do, for part B, I'm going to do the integral between C, which is minus a quarter, up to A, which is 1 of y. And then I'm going to add to that this triangle. Now, I don't know the height of it yet, so I'm going to work that out now. But I can easily find that by putting 1 into here. So obviously, if I put 1 into this equation, I'll find out what value that is. So I've got 4 plus 9, which is 13. 13 minus 30, and then minus 8 is what I'll get in there. So 13, so 4, let's do it all properly. Don't want to mess up again. So 4 plus 9 minus 30 minus 8 gives me minus 25. So that's down here. So I know this height is 25, and I know this gap along here is 1. So I'm going to do 1 times 25 divide by 2, and that's going to tell me the area of this triangle over here. Let's call that T for now. So the area of T is minus 25. We'll just do 25 though, because we know that needs to be positive. So 25 times 1 divided by 2. So that's what we're looking at here. So let's actually do this. So the integral of this y value, let's actually integrate that. So 4x cubed, when we integrate it, is x to the 4. 9x squared is 3x cubed. Minus 30x is minus 15x squared. And finally, we've got minus 8x. We want that between minus a quarter and 1. And we're going to add to that 12.5 when we finish up. So this will be our total area. So let's just stick something like that. So if I put 1 into here, I get 1 plus 3, which is 4. 4 minus 15, which is minus 11, and then minus another 8, which is minus 19. From that, I need to take away when I put minus a quarter into here, which I'm going to do on my calculator. So minus 0.25 is going to go in. And then I'm just going to put in this actual thing. So ans to the power of 4 plus 3 ans to the power of 3 minus 15 ans squared, and then minus 8 ans. Whoa, let's actually put that in there. Minus 8 ans. So that gives me 261 over 256. So 261 over 256. Now I want to do, I just want to check when I put 1 in here, actually make sure I got that right. So I'm going to put 1 equals, press up and press equals, minus 19. So there's that. Just going to go back to this again. Whoa. Let's actually put quarter back into that. There we go. So now what I want to do is subtract these. So I've got minus 19. Take away that ans, which gives me this weird number. And then I actually want the actual, so I've got plus 12.5 here. But because this is negative, I need to actually think about this carefully. This is not strictly true because this is a negative answer. So this is not actually true. I actually want to take this away. But we knew that we'd find an area here, so we should think about that rather than just whacking all this in our calculator. So this is 5125 over 256, and then it's plus 12.5. So I've made that positive. So making that positive, and then adding to it 12.5. So my final answer gives me this. So 32.52 to 2 decimal places. Now we're going to try it using our calculator to cheat. So using our integral button. So I want to go from minus put the limits in first, minus 0.25 up to 1. And I want to do it of this thing. So remember to put your original in. So 4x cubed plus 9x squared minus 30x minus 8. And then once I work that out, I also want to take away 12.5, and then I'll make it positive. That gives me this thing, which is 32.52, and then making it positive. And that is, of course, square units. And that's it from these ones. So there's a load of example questions for you to have a look at and see if you can pick some techniques up from what I've used there.